evening everyone. I'm Suraj. So today I'm going to talk on statement presentation on the topic of numerical and experimental analysis of triple layer organic PLA structure. Triple layer is nothing but fused filament fabrication. Okay, so these are the my presentation of outlines like backgrounds, applications, methodology, and 3D printed object structures. Comparison between numerical and experimental results and conclusion. Okay, so background, I just want to start with the first this image. So actually this I am using in this project PLA. So PLA is nothing but polylactic acid. So it is a type of shape memory polymer. So it is different from alloy. So what happened here is that when you deform a polymer, so it creates a temporary bonds, and when you heat up above the glass transition temperature, then it creates it again creates a new bond, that imaginary bond. So here you can see that this is the temporary structure, and when you deform it like up to 50%, then again if you are heating above the glass transition temperature, then you can recover its shape. So like the mechanism is just if you are heating above the glass transition temperature. So this structure is called like meta structure, which has negative Poisson's ratio, and it is good for energy absorption kind of application, load bearing capability, and for damping kind of application. Okay, so it comes like for application, why we are doing this. So application is still exploring, but like objective is mostly like preferable for biomedical kind of applications like footwear, medical, and some cardiovascular and orthopedic applications. Okay, so methodology is like first geometry selection is the main part for this kind of application. So I have selected like this S type of a structure. So this is I have just called simple structure. So this is like from literature, and I have based on the FE analysis, the deformation model, I have tried to change that geometry so that it should able to take more load, and meanwhile it should be capable to taking the soft kind of loads. So this structure is my structure, which comes from the modified. In this I have added the stringers. So this is I have called modified structure. So I have done the FE analysis. So in FE analysis, the property I have kept elastic property is Young's modulus and Poisson's ratio, and again the material property for plastic properties came from the experimental data. Okay, so FE analysis is for meshing, the next step. So meshing is done like I have kept 8 node linear brick elements. So and after that I have done the grid independent test for the element size kept at 0.5. Also the interaction has been defined, so that in real case what happened when you do the compression test, the with your models, the interaction is different, like what with your model and the uppercase of the machine UTM. So somehow the case has been maintained, and here like surface to surface contact has been used. So again the boundary condition is similar to what we do in UTM. So like bottom is fixed and other top is like movable. So here one more thing is retracted. So in real case when we do a compression test, so what happens when after reaching to a certain like displacement, you are going to remove the upper case. So same thing has been created in the software. So after reaching to like some displacement like 5 or 4 mm displacement, that interaction has been removed, so that you can see the permanent deformation. So these are the like this is the structure which is printed 3D printed like a triple element method. So the printing material is PLA, polylactic acid, and filament diameter is kept as like this is standard one 1.75 mm. So extruder temperature kept as for PLA is like in between 190 to 230. So these are like these are the printing parameters which has been used for this PLA structure printing. So bed temperature is printing temperature is kept as 250. Bed temperature is kept as 15 degrees Celsius. Printing speed is for customized kept as 40 mm per second. Field density is 100%. So that the structure should have more strength. That is why it came. And field pattern is triangle. Since the thickness is very low, so it should be suitable for that particular thickness. And layer height is kept at 0.225. Okay, so again it comes like comparison. So this is the comparison for a simple structure. So if you see the simple structure, experimental and numerical result. So in this structure, you will see the deformation is only occur in the particular section, like below section. So this structure don't have the deformation in all the like section. So what I want is the deformation should be in the all the section. Okay, so after like modification, you can see that a deformation is in all the like load has been distributed all the sections. But this case was not there in the previous one. So if you see the experimental and numerical result, it's quite similar. So here like you can see even in numerical and experimental one, the deformation is same. So for MS structure, which is nothing but modified structure, the maximum force is reached up to 550 Newton, and while experimental result is 670 Newton. While in case of simple structure, which was the literature was like the even maximum force is reached up to 420 Newton only. But if you, after modification, the force has been increased. So let's come to the experimental video. So you can see the experimental animation video. So for this case, the distillation has been kept for 2.5 mm. Same case for FE analysis. So here you can see like after the reaching to the 2.5 mm, the interaction has been removed, so that you can see the permanent deformation in the real case if you are doing the compression. Okay, so now come to the conclusion. So conclusion is the maximum force which we got from SS simple structure was 555 Newton, and minimum which we got is 119 Newton. So minimum is nothing but the like, since we have repeated the structure in subsequent part, like so in that force we got like 119 Newton. So and also we can see that the, for SS structure was the deformation was not uniform. We can see the lower section has more deformation if you compare with the other section. So that comes like problem with this structure, and that not exhibit the objective behavior. So to overcome that those problems, the structure needs some modification, and that is why the structure has been modified with the addition of stringers. Okay, so that new structure is modified, and with that we can we are able to achieve 670 Newton force with the minimum force like 450 Newton. Where you can see the simple structure was minimum force was 455 Newton, and here the minimum force is like maximum force was 455 Newton, but here minimum we are getting 450 Newton. So safe recovery of MS structure varied with cycle, like also the safe recovery has been taken care in this. So we like for initial cycle we got is like 99.5 for and remaining cycle was 97.5. So the numerical and experimental result is compared, and the showing maximum force was 550 Newton, and for experimental and numerical was 60 Newton. Okay, so one more thing, like structure is failed like after 6 cycles, but again we have tested and it was able to reach the force up to where it fails in the next subsequent cycle. So these are the reference. Thank you.